Alright, so today is 27/03/2024 and we were talking about BERT. What is the full form of BERT? Bidirectional Encoder Representations from Transformers. So, this heading tells you everything what BERT entails. So, bidirectional means, so you are not talking about things like language modeling where you can see only the left of the word. So, you can see on both the sides. Encoder means, so there are no decoders involved, only encoder. Representation is something we know, right, and transformers we have already covered. So, we had talked about, in a way we have already talked about BERT. So, we have talked about BERT large architecture, we have talked about, so just to recap, because the class, the gap, there has been a gap of almost 8-9 days, what we were doing here. So, we talked about the task on which BERT was pre-trained on. We have already seen the architecture. So, this is some, okay. Now, I won't go beyond this one. D model for BERT is, for BERT base is 768, for BERT large it is 1024. Okay. So, we have talked about the number of parameters and everything. Pre-training. So, BERT was pre-trained on which task? So, what is MLM? Masked language model and next sentence prediction NSP. Okay. So, masked language model, what is this? Predict a random 15% of subword tokens. Okay. So, you are not expected to predict what comes next, this is not language modeling, but you are still expected to predict some word that is masked. So, we will go into the details of these things now, we will go into the details of these tasks now. Okay. So, it was trained on huge corpus, you can see there are roughly 3300 million words, but okay, today's large language models, they are trained on a much bigger corpora. Okay. So, we start with this now. Let me see. So, let me try to draw the diagrams as they have done in the BERT paper itself, right. So, I am at figure 2 right now. Let us start drawing figure 2. So, how do you give input? So, what I am trying to elaborate here is this one. So, we have talked about these things. Right now, I am going to talk about what happens here. Okay. What happens here in general? You are supposed to give input. What will you do in case of GPT, the OpenAI GPT? Embeddings plus positional embeddings and feed that. Okay. BERT does this thing differently. Of course, you can't be radically different because still you are supposed to give inputs, what embeddings will still be there. Okay. But BERT does it a bit differently. So, what happens here is you have position embeddings. What else you will have here? So, BERT has something called segment embeddings too. What else you have? token embeddings. Okay. So, if you have some, so let us say if your input is something like, so I am just drawing the figure from the paper, CLS, this is a special token, we have seen this in the last class. My dog is cute. Now you have a separator token, and then he likes play # ink. Okay. So I'll just keep it there, even though they have just one more thing, I won't go into that now. Okay. So what is CLS? So CLS is a special token in BERT. Okay. You start from, so what will be the, how will I feed this particular sentence to BERT? That is the question we are asking. You need to have something called position embeddings. How many positions are there? How many positions are there? How many positions are there in BERT? 768 is my D model. What is capital T for BERT? 512. Okay. So you have 512 position embeddings. What will be the size of my position embedding matrix here? 768 cross 512 or 512 cross 768, whichever way you put it, right? So this will be a thing of 512 cross 768. Now let us always keep 768 as the second dimension, just because we have written it this way here. What about segment embeddings? See, BERT, so this is segment 1 for BERT. Okay. So this will be, you know, segment. How many segments will BERT have? Two. Okay. So let us keep them here. So this will, so if there are two segments, what will be the dimension of these segment embeddings? No. SCP, so I'll come to these things. These are part of vocabulary for BERT. Okay. SCP basically means, or the CLS will be just one, your first token used for classification. Okay. It's a special one. Now SCP is the token that you use for separating things. So you want to say this chunk of sentence is different from this chunk of sentence. Nobody stops you from having more than one SCP as they have it, you know, in the paper itself. But in general, I mean, what I have seen most of the times is it starts with CLS, then you have your sentence 1. Remember, we had drawn this earlier too. Here it is. So you have segment 1, segment 2. Now this can be a continuous piece of text from your corpus. This can be a continuous piece of text from your corpus. So for example, if you take the SQUAD data set, SQUAD question answering data set from Stanford, this can be your question, this can be your comprehension. So separator basically tells that these two segments are potentially different. Now when you do next sentence prediction, you do that same thing here. So you give S1, you give S2, and the question that you ask in this NSP is whether S2 follows S1 in my corpus. Okay. So what you do in NSP is the following. You give BERT two sentences, and when we say sentence, see, all these large language models, they are basically questioning human understanding of languages, right? Because you do things in all these weird stuff that we have never heard of, that we don't even think will work, but those things are actually working like a charm. How many of you have read that article I had sent? Right? So, see, like when we'll come to BERT tokenizer, then we will be actually more surprised. So, I've heard Geoffrey Hinton once saying this thing. So, linguists were studying, everybody knows syllable. What is a syllable? Sound, right? So, if you want to break our speech into atomic things, linguists say they break down to syllables. And when you do speech recognition, machine does not care about the syllables defined by human beings. Similarly, human beings have been, say, for example, this word predict. What is the meaning of predict? Okay, let me take a simpler word. Let's say water. What is the meaning of water? Water, right? We don't need to define it. But you could have kept some other name for water, and the same thing will still go through, right? So, who says your vocabulary has to be, number of words in your language? So, large language models, they have been essentially questioning these kind of fundamental things that, we human beings think you can't really do away with. Similarly, in this NSP prediction, what the paper says here is your S1, so even though we are calling it sentence 1 and sentence 2, they explicitly mention in the paper that S1 doesn't have to be a sentence that a human being thinks of. So, it doesn't have to, it can be any arbitrary contiguous chunk from your corpus. So, it doesn't have to be a sentence the way we think a sentence should be. Any continuous chunk, wherever you start, wherever you end, right? That is my sentence for this purpose. Similarly, S2 same. What is the question we are asking in this next sentence prediction? The question we are asking is a very simple, it's a binary classification question. You have to just predict whether S2 follows S1. So, how do they train it? They, they prepare this data set such that 50% of the time S2 follows S1 and 50% of the time S2 does not follow F1. It's a random piece of text from my corpus, and the system is supposed to predict that, the BERT is supposed to predict whether S2 follows S1. See, it will be much better if you keep it interactive, because the whole point of doing all these things is to make our understanding better. So, if I want to input this, my dog is cute, he likes playing. So, first of all, tell me, if I ask you this NSP thing, the next sentence prediction question here, what should be the classification? What should be the classification? Yes or no? Yes or no? Yes. Okay, why yes? This seems like a logical. So, this is my S2, this is my S1, and it looks like it is okay to say that this particular sentence comes after this one. Okay. Now, how do we input? So, we know position and embedding input are of size 512 cross 768, segment embeddings. So, this is my segment 1. So, let me just try to write it here. Let me just keep it the way they were keeping it. So, there is a separator here. Okay. What is this EA and EB? So, these are my segment embeddings, right. I will have two segments S1 and S2. Okay. So, this SEP, so this whole part belongs to my first segment. After SEP, this whole thing belongs to my second segment. So, how many segments will be there? There will be only two segments. Okay. So, what is the length of, what is the size of embedding slant here? What will be the size of segment embedding here? Huh? 2 cross 768, right? Because we are just taking this convention that 768 will come in the class. Now, everybody agrees that since we are going to add all these people as we have been doing until now, they should all be of dimensions D model, which is 768. Okay. So, I can write here without thinking this one. Now, my question is, what will come here? Five and two. Okay. Positions are only 5 and 2, but tokens you can have as many as in your vocabulary, right? So, BERT fixes these parameters or it learns them. So, BERT learns all these parameters. Okay. Now, position embedding. So, let me just try to write whatever. So, this is your embedding 1. I mean, okay, they are calling E's, but shall we use P? That is what we have been doing until now. So, I hope it won't conflict with some other things somewhere else. Okay, they start with 0. Now, this is my E, CLS, this is E, my, this is E, dog, and you add all of these. Okay. So, this is what the figure 2 of paper is. So, this is what you are going to feed to BERT now. Okay. So, what will be your x1 token that you will feed into BERT? Addition of all these three things, and these are all and you basically learn all of them. Any questions in here? No, what you are saying is that this segment is different from that segment, that's it. So you are trying to, so else it will look like this whole thing belongs, I mean how would you, use this separator otherwise, okay. So what all this embedding is doing is, this belongs to my first segment, this belongs to my second segment, that's it. Like here you have 512 positions, so you say this is for my first position, this is for my second position, similarly this is for my first segment, this is for my second segment, okay. Now so let us, I think we have done BERT, nothing remains as such, but I still want to go into the details. So let us see if we can talk about pre-training now. Yes, so I have talked about the task, right, but let us go a little bit more into the details of it. Now, so let me just try to the pre-training tasks are the following. So for example, if we are supposed to, so I am just taking examples from the paper only. So let us say the unlabeled right. So let us say I want to do this thing. So I want to use this token mask. So what is MLM? What are we doing in MLM? So 15% of the words are masked and they are chosen randomly, right? Of those 15%, what do you do? 80% you use mask. So for example, if randomly chosen place is 4th, then basically how will you mask it? My dog is mask, okay. What else? 10% of the time, so this is what we do 80% of the time. 10% of the times what am I supposed to do? Replace. Replace with random word. So this becomes my dog is apple, for example, okay. So this is my original sentence. If I mask, it becomes this. If I replace, it becomes this. And what happens remaining 10% of the times? So keep as it is. What will that mean? My dog is hairy, remains as it is. Now, see how do these tasks help us? I mean, why are these helping at all? Will you ever be using these things for training, I mean test time? Are you ever going to, how useful is this task? You are given a sentence. How many times, how many of you will do this? You give machine a sentence and ask it to fill in the blanks. Almost never, right? So the task in itself is of no use. Why is this useful then? See, yes. So the things that large language models or the things that transformers have been able to achieve is you train it on one task, right? Almost never test it on that. You don't really care how good is their performance on the training task. You just train, and train. Okay. Once you sufficiently train, you keep those weights, right? Now do fine tuning on the particular NLP task. Okay. So BERT mentions these tasks. I am going to read them for you. So I have already talked about the NSP thing, we have talked about the MLM thing. So they have trained the BERT with batch size of 256 sequences into basically 256 into 512 tokens for 1 million steps, which is approximately 40 epochs over 3.3 billion word corpus. Okay. What does it mean to say for 1 million steps, which is approximately 40 epochs over the 3.3 billion word corpus? What does it mean? My question is this: what is 1 million steps, which is approximately 40 epochs? What does this line mean? Yeah, 1 million steps, which is approximately 40 epochs. Yes, what is it? So that is what epoch is. So I think you know. So what this means is, they say here we train with batch size of 256 sequences. So batch size is 256. So 256 batch size, how many in one batch? Sorry, one batch means 256 sequences, right? But so how many tokens in every sequence? 512. So you take 256 such things. So 256 into 512. This defines your one batch. Now when you say 1 million iterations, what does it mean? 1 million steps basically. See, you are going to use which gradient descent? Batch gradient descent, mini batch gradient descent, or stochastic gradient descent? So we don't use batch gradient descent when we train such a large model. What we use is stochastic gradient descent. But what is the bookish definition of stochastic gradient descent? We don't use that either. What we use is, so whether be it TensorFlow, whatever it is, be it papers, when they say stochastic gradient descent, they actually mean mini batch stochastic gradient descent. So basically mini batch gradient descent. So in every iteration you are feeding 256 sequence, each sequence is 512 long. and you do this almost 1 million times, right? This thing means, so what is a epoch? Epoch is during training when you iterate over your corpus once, that is epoch. So when you do this thing 1 million times, that is roughly 40 epochs. Okay? So if you were to do batch gradient descent, what does that mean? You will update after running over the whole epoch. Stochastic gradient descent, you will update every batch, not example, every batch. Okay? So that is what it is. Now what else? So they use dropout of 0.1 on all layers. The training loss is the sum of the mean of masked LM likelihood and the mean next sentence prediction likelihood. So can you tell me what is this now? What is the loss function for them? So I repeat, the training loss is the sum of the mean masked LM likelihood and the mean next sentence prediction likelihood. You should be able to do both of these by now. So first of all, it is sum. So sum of what? So I am going to put something here. So this is my total loss. This is coming from MLM and this is coming from NSP. Now what is NSP? I won't fill in this here. This you are supposed to do it on your own. Yes, what is NSP? This is just binary classification. So I'll write that, but I won't write mathematics still. This is my binary classification. And what about this? What about this MLM here? Which loss will you use for MLM? Binary classification के लिए what will you use? So that is cross entropy, right? What will you use for MLM? Cross entropy, but which one? You have done this. This is what we have been doing throughout this course. What is it? What are you supposed to predict? What are you supposed to predict in this case? See, I'll gradually make a shift from words to tokens now. Okay? So you are supposed to predict a token here. Your token comes from which set? Vocabulary. Okay? So basically you are going to do a softmax over, so mod V. But is this the loss function? No, this is not the loss function. So what will be the loss function? Right, that cross entropy thing that you have been saying. So this is cross entropy, this is cross entropy, you take sum of both, that's it. Okay, so this will be summation log pi and this is also summation log. So this is done. Fine tuning procedure, batch size, they take differently, learning rate, number of epochs. So you see the number of for fine tuning, their number of epochs is 2, 3 and 4, much lower than training the whole thing. Now comparison with OpenAI GPT. I will not compare it with Elmo. Elmo was a good architecture, but suddenly got washed away because you suddenly have this transformers here. Elmo was LSTM based. Okay. So, this is fine. Now, what is the difference between GPT and BERT? So, I think the difference also you know. So, now the task, the benchmarks that they tested BERT on, MNLI, multi-genre natural language inference. What is natural language inference? We saw this when we were doing GPT. What is natural language inference? So, you were given 2 sentences. What was natural language inference? See, when you were given 2 sentences, you were supposed to tell whether the second one entails from the first one or is a contradictory or is neutral, right. So, there were 3 classes you were supposed to answer on. Okay. So, entailment, contradiction or neutral. Now, can you do this using BERT? BERT comes up and says they actually do better than anything that existed until now. Okay. Then there is another task which is Cora question pairs. So, this is a data set. Cora question pairs is a binary classification task where the goal is to determine if 2 questions asked on Cora are semantically equivalent. So, whether 2 questions, so again, so you know this segment embeddings now they come into picture. You give first question, you put SEP in between, you give second segment, you learn the segment embeddings, of course position embeddings, and finally what are you supposed to answer? See, so finally the way BERT works is, so I will just use it here. So, see, finally this is your BERT. So, I am just talking about this CLS now. So, like everyone else, CLS will also go all the way up until, so this is my 12x encoders, okay, encoder blocks. You will have CLS here as well. So, you use, what are the dimensions of this CLS? What are the dimensions of CLS up there after passing through all the 12 layers of encoders? How much? 768 cross 1, there is not much to think about there. This vector, tell me, this vector, whether it has received information from all 512? Yes or no? Yes, because this is bidirectional, this is encoder only. So, to compute all these, you are actually taking dot product with the later ones as well, right. So, this particular encoding is very special in BERT. You do all the classifications using this. So, you do not do this. Finally, you will have how many outputs here of what size? Finally, you will have 512 outputs, each one of size 768 cross 1, but you do not use a sum of that, you do not use any of these 5, 1, 11. What you just use is this first vector, that is 768 cross 1. So, how am I going to do this natural language inference? You have this 768 cross 1, take it as softmax over 3 classes, right? Contradictory, entailment and neutral, done. Similarly, Cora question pairs, you are given 2 questions. So, one will be your segment 1, another one will be your segment 2, pass it through this whole thing. It's a classification task or it's a generation task? Classification, because you are just going to say yes or no. In fact, eventually even generation is also classification, because every time you are doing a classification over mod V, but we don't call that classification per se. So, this is done. Next is natural language inference. So, question natural language inference is a version of Stanford squared data set, which has been converted to a binary classification task. The positive examples are pairs which do contain the correct answer, and the negative examples are the pairs from the same paragraph which do not contain the answer. So, squared data set is the following. You are, so I think I am writing it right. So, squared data set is the following. So, squared data set is this one. You are given some context, you ask a question, okay. In you are supposed to, so you are given these 2 things, you are given a context, you are given a question, and you are supposed to tell me what is the answer. Now, the specific, does this require me to generate something? Question answering in general requires me to generate text, but BERT is not at all good at text generation. It is super good at classification, but you can't use it for generation. Why not? Why not? See, what is the primary ingredient of a generation thing? You, during your training time, you should be trained such that you don't have access to what comes later. But BERT has access to left and right context both. So, the very first step during the training that was taken, which was anti-language modeling, because language modeling prohibits you to have a look at what comes next. Here you are training on both the directions, right. So, BERT is not at all a good model for generation. So, but question answering requires language generation. So, what kind of question answering is this? You are given a context, question, so your answer will be something like this. Let us say context is from word number 1 to 100. So, your answer will be like this. My answer starts at place 42 and ends at 68. So, this is my answer. I am not generating something for you. You gave me context, you gave me question, I am saying the answer is start from 42 and end at position 68 in this context, right. Again, does this become a classification question? This becomes a classification question. What happens? Everywhere you ask this question, whether it is the start, you ask this question for all 100 positions. Wherever you get the maximum probability, so let us say in this case, you will get maximum probability at position 42 for the start token. Similarly, you will have something called end token. So, the probability at 68 was the highest for end token, and that is where you, that chunk you reply as the answer. See, you are having just these two special things that you are learning, start token and token. That's it. So, the way you do, if you are supposed to compute probability over 100, how will you do that? See, by now you are an expert on this. So, that is why I am not taking this in detail, but let us discuss this. You are supposed to give me a probability distribution over how much? Length of my context. Length of my context. So, how do I do that? So, it is a softmax over length of my context, that is done, but how do I again see, to be able to compute probabilities I must do some computations before that. Take dot product with something, that will give you a number. So, what should be the size of my start token? It has to be 768, because every damn thing that I am doing has dimensions 768. You take dot product with this, you take dot product with this, you take dot product with all 100 things, compute softmax, whichever comes the highest, there you assign. Okay. So, similarly, Stanford sentiment tree bank corpus of linguistic acceptability, अब इधर सुन लो, corpus of linguistic acceptability, semantic textual similarity, Microsoft research paraphrase corpus, and so on. They have so many of the tasks, and they show that BERT outperforms every model trained before it, specifically OpenAI GPT. Yeah. No, you create this data set such that you make it a classification problem. In general, question answering is a generation problem. Right. See, what I said just before is, even generation is classification. You are classifying over mod V, right? But in this case, you are doing something very, very specific. All you are supposed to classify, so the classification here in this case is, given these 100 things, right, which is my class where I should start. So, I am not doing a classification over mod V. As long as I am not doing a classification over mod V, I am not doing generation. Make sense or no? Questions then? See, depends on how you are given data set. So, Microsoft research paraphrase corpus consists of sentence pairs automatically extracted from online news resources with human annotations for whether the sentences in the pair are semantically equivalent. So, you are given two things, you are just supposed to say yes or no. Okay, so go and have a look at this paper. I think I don't think there is any detail which is LLM specific and I have left in this paper. What will be the effect of model size? Which one do you think will perform better, BERT large or BERT base? See, Elmo was a nice architecture, but killed because it happened to come at the same time when transformers came, almost at the same time. And there are so many BERT variants. You will find ALBERT, Albert, you will find Roberta, you will find Distilbert, you will find so many other variants. Every domain made their own BERT. There is something called legal BERT, there is something called, I think MedBERT, there is something. BERT has been super successful, but it was known only to the research community. GPT took that to the next level. It became famous to the masses. Now, these papers, Roberta, Albert, they are no different from BERT. Some of them will come and say, see, you don't need NSP as a task. Some of them will come and say, you don't need that part, this part. Still BERT will come and say, we want to keep only those parameters which are important and so on. So maybe I'll refer you, I mean, you can do it on your own, basically. So that is it. Questions from your side. What is still left and is an important thing is how do you prepare, So I can no longer escape from this task where I was saying, so I must start dealing with tokens now. What is the vocabulary for BERT? It is 30522, so roughly 30,000, right? And it has a lot of rich vocabulary. You might find some tokens of Hindi, English, Spanish, French, Russian, Mandarin, numbers, names. In those 30,000, it covers everything. So I think that is it for today. Okay, we'll start this as a separate topic in itself. Is this question answering part clear? Because I think that is the only complex thing we covered today. Rest everything was just the details of BERT. But BERT is still relevant today. If you will go to industry, BERT is still relevant. If your company cannot pay for OpenAI APIs, this is what you will do. Okay, yes. Done? All right.